The focus in exercise 702 is obviously on the gradient. Now, the gradient concept will appear in the three places. For example, when I say three places, one is the equation. So we should be able to read the gradient from an equation. Two is a table of values. We should be able to read the gradient from a table of values. And then three is the graphical form for a function. And we should be able to read the gradient from the graph. So three different ways of representing a relationship. And in all three ways, we should be able to identify the gradient. Now, we know that in its equation form, a linear function is y equals mx plus b, and the value in front of the x will always be the gradient. So that's pretty straightforward when you've got an example like, I'll just draw it over here, y is equal to 5x plus 2. You can say the gradient is 5. If you've got y equals minus x plus 4, the gradient is negative 1. And when you've got y is equal to 2 plus x, now don't be tricked by that one. The gradient is the number in front of the x. The gradient is 1. They often give that example and test that you really understand that the gradient is the number in front of the x. It's not the first number that appears necessarily. In a lot of cases it is the first number, but that's only because they've written the x term first. So just be aware of this situation. Okay, let's move on. How do we get the gradient out of a table of values? Well, we use this understanding here. So gradient can be defined as the change in the y value divided by, make a fraction, change in the x value. So if I look here, the change in the y value from 3 to 7 is 4. From 7 to 11 is 4. So the change in the y value is 4. And the change in the x value from 0 to 2 is 2, from 2 to 4 is 2, is a plus 2. The gradient is 4 divided by 2, and you can do that on your calculator, and you'll see the gradient for that table of values is 2. The gradient is 2. We would know that we could write y equals 2x, and we would find our b value, which we'll focus on in a next exercise about y-intercept. We're focusing in this exercise just on the gradient. So, you've seen, given an equation, how to get the gradient. It's the number in front of the x. Given a table of values, how do we get the gradient? It's the difference in the y over the difference in the x. I'm actually going to leave these two, and I'm going to talk about those in class. So I'll be hoping that when I ask, how do we do this, you have all learnt this now. And you can say, to find the gradient, when you're given a table of values, you're looking for a fraction made up of the change in y in the numerator and the change in the x in the denominator. You then simplify that fraction if needed. Now, to find the gradient, when we've clearly been given a graph, the process that you need to follow is 1. you find 2 points on the line. Now, it's made a little bit easy for you here in this example because you can see the point here. I might do that in red. Here's a point and here's a point. And what we're going to do from there is to use M is, the gradient is the rise between those 2 points over the run. Now, the rise is this component. I know you've done this before, so please make sure that you're really registering it now, because this is going to be examined in the HSC. I've got to start to realise that everything you do has to be learned for the long term, not just for this topic test at the end of, in a week's time, but right through until October 2019. The rise it's a positive rise. We've gone from -3 up to -2. That is a positive one. Over, and how far did we run? We went from x is 0 across to x is 1. So the gradient is 1. And step 3, check the sign. Now by that I mean, is it positive or is it negative? And from your understanding of the look of the line, I know my answer should be a positive because the line is sloping up. Did I get a positive one here? Yes, I did. Okay, you should be then right to jot down your summary and your key points and then do exercise 702.